Hi all, my name is Thomas Wilkinson. I'm a fourth year electrical engineering student at CSU and I'm enrolled in ENGR300. This is my final design project. I have created a 3D printed 12-digit keypad case. However, with this project, I intended for it to actually incorporate the full keypad and eventually get it to work with an Arduino where I can actually read out which pins are being pressed. However, until then, let's get into it. So as you can see here, as I just mentioned before, the purpose of this project is to build a 3x4 keypad so that it'll have essentially 7 pins that can be connected to a microcontroller that can be essentially put either high or low and can be read as signals in order to determine which buttons are being pressed. Clearly this is not a 100% original idea, but at the same time there's a lot of variations with this. As you can probably imagine with any computer keyboard or other simple devices in which require a number of buttons, especially in an organized array, there's going to be some sort of matrix for telling which ones are being pressed and having the least number of pins to do that. This here is the way of doing that. Now, my goal, at least in regards to design, was to create 2 different pieces that would encase a circuit board with these buttons. And I used PETG plastic mainly because, from what I have heard, ABS can be a bit brittle and PLA can morph with too much heat. So I wanted something that was a little bit more robust, and I'd heard that this was a bit in the middle, or at least hence what my research had suggested. Going forward, I wanted to make sure that the circuit board was comfortably sitting inside the case. I didn't want it jumping around too much, and I wanted to make sure that someone could hold it, shake it around, not have it rattle, and also be able to press the buttons without feeling resistance from the case. So yeah, moving forward, this is the case, at least the top part, in which I've designed. Here I actually based most of the dimensions based off of measurements I had taken from the buttons themselves, which we will see in later slides. The buttons were composed of 2 different parts: the head of the button, where it's essentially just a plastic piece that that users actually interact with, and then the mechanism, which is a lower part where a user will hear it click whenever the button is being pressed and then released. Just as well, you can see in the design those the 12 main circles there are clearly designed for those, and then there's also 2 additional pins there, or 4 additional pins in the middle, and those are, like I said before, to sort of suspend the board in a way that it's pushing it away to keep the buttons from being pressed up against the case itself. Clearly there's no point in trying to press the buttons if they're already being pressed up against the inside of the case. With that said, research had also suggests that the diameter of circles being printed may end up differing by 1 full millimeter because of the way that it gets printed. Because of this, I decided to add a millimeter to the diameter of those larger circles, where I knew that the diameter of the button was quite crucial. Additionally, as you can see on the front end of the case there's also an opening so that wires or any sort of other pins can be accessible via the user. This is really helpful. I meant to make them 2 different dimensions, so that one would have 3 pins coming out coordinating with the 3 columns, and the other one would have 4 pins coming out coordinating with 4 columns. And so that would allow at least other users in the future, if they decide to design the interior a little bit different, that gives them flexibility in that area. Moving forward, we see here is the bottom of the case, and with the bottom here, pretty much the goal of this was to make sure that it would very tightly fit on with top of the case, in a way where it wasn't like loosely falling off, but then again, it also needed to be able to actually get in. Fortunately, my decision in this was to make the pieces that would align on the inside. I decided to make them the exact same dimension, and it just so happens that with just a very, very light amount of sanding, I was able to get the two pieces to fit together in a very snug manner without falling apart. Additionally, you can see on this bottom piece, I actually had more pins down here too. And you would think that you would only need pins on the top part because that's where the buttons are. However, down here, one needs to realize that on the circuit board, there's a lot of soldering that takes place. And the soldering is clearly not like identical everywhere. In fact, it gets very rugged on the bottom of the circuit board. So because of that, I needed pins to hold that up in order to give room for wires and such to move about in the bottom. Additionally, you can see at the front of this piece, there are two pieces that are the exact same width as the two slots in the previous slide here. This way, the two slots are not entirely that large. It essentially allows the user to have an encapsulated output for the pins without having to print it using structure or any sort of support material. So essentially, moving forward, here is the assembly design, and as I said before, you can see at the very front of it how how now there's a very nicely enclosed slot. You can also see in the figure in the very middle of the screen how there is 1.63 millimeters in between the top pin and these bottom pins. That is the diameter, that is the width of the board in which I put in there, which made it very snug and made it not rattle when it was moving around. This was also super helpful for when I was testing to make sure these parts would fit together before actually printing it, because I actually at first had designed these two parts, thought they were just fine, and then put them together in the assembly and realized that I had dimensioned them from the wrong, dimensioned the two front pieces of the bottom board from the wrong position. So clearly I had to revise that before I actually went to print it. Moving forward here, I would say the best features of this board are, for one, I filleted the outer edges, so those are smooth. The interior pins for positioning of the circuit board, I think that it'd be very hard for like a machining lab to go do this. Now, clearly, maybe this could be, this is very doable if you were doing some sort of cast, or injection molding system. However, for a 3D printed part, I would say that this definitely is a benefit for that. Additionally, the buttons can be pushed without resistance from the case. Like I said, the two outlets allows for easy access to all 7 pins. They fit together really snug. I had also had to sand down the front surface, mainly because it was a little bit rugged coming off of the printer for the first time. But fortunately, like I said, the design didn't require any structural support. I had used the button measurements for all the part dimensions and adjusted them in order to reflect potential errors. So, what are the lessons learned from this? Well, for assemblies, for one, you got to check to make sure that they fit together beforehand. This could definitely introduce a lot of problems. Also make sure that the printer has a clean surface before trying to print on it. That is the reason why I had to sand down the surface to begin with. Fortunately, it looks good now, but when I took it off the first time, I certainly could have done things better. Additionally, on the rep wrap, I had some problems initially printing the bottom part, mainly because the bottom head, the head of the extruder kept being too low or too high, and I had to get that, right before I could finally print that off. And then on top of that, really, while this is not a mechanical or a 3D printing problem, when it comes to soldering, I think that soldering is kind of a skill that really takes time to learn, and I didn't expect it to take as long as it did, but it definitely took a while. So I figured I'd put these two pictures here so that you can see just how I put it together and what the innards really look at. You can see how I decided to kind of make the colors different with the green buttons. Those are meant to be like if you're like playing a game and you want up, down, left, right. Black buttons would be like star and pound sign, and the rest of the buttons would just be like 1 through 0. So really, what would I do next time? I would look for really just making the circuit board smaller in general. I would try to use like ribbon cable instead. I would try to make, more rounded edges, even though that would, require support. And then in general, I think that it'd also be nice if you could build a case that instead snaps together, instead of just relying that the print is going to come out the same way in order, expecting it to just stay together. Also, I think it'd be really cool to have LEDs in this, because why not? So moving forward, I think that, if I can create an Arduino program that can actually test all this, make sure that it works properly the way it's supposed to, really this can be put to really good use. Anyway, thank you so much for watching. I hope you have a really good day.